guys, this is Dr. Possibility from Excel Academy. Welcome to our mathematics revision class, and in this class I'll just be solving the tutorial sheet 1 of Vunza Math 1100. So please make sure that you subscribe to our YouTube channel and make sure that you register with Excel Academy. So let's quickly look at the first 3 questions. So in this tutorial I'll just solve question 1, question 2 and question 3. So please make sure that you ask questions in the comment section in case you have questions, and in case you want to register with us, feel free to WhatsApp us. So let's quickly start with question 1. So question 1 is saying let U be equal to that, the sets A be equal to that, and B be equal to that, and C be equal to that. Find the sets, this one, that one, and that one. So I'll write my solution like that. So the first thing that I'll do is just to simply look at these sets and see if at all these sets are intersecting. So from here I can see a 6 there, I can also see a 6 there, I can also see a 6 there. So by noting these 6, I can easily tell that all these sets, they are simply doing what? They are simply intersecting. So with that information, I can easily come up with a Venn diagram which will work very well for me. So I'll put set A and then I'll put set C down there. So this is my Venn diagram, and this Venn diagram, what I'll do is that I'll put it into the universal set, since this is just trying to explain that all these 3 sets are simply subsets of the universal set. So this will be our set A, this will be our set B, and this one will be our set C. After analyzing this, I'll start by simply putting the one which is in all the sets. So I have 6 there, I have 6 there, I have 6 there. So this simply means that 6 is going to be located where there is a intersection B intersection C. After I take note of that, I'll find the set which the member which is in A and B. So what I found is that A intersection C intersection B is simply equal to 6. So this is the only element which is in A intersection B intersection C. So after I do that, I'll look for A intersection B. I'll look for A intersection B. So A intersection B, what I'll do, I'll look for the sets which are in A and B. So if you check very well, 8 and 6 are the ones which are in both set A and B. So I'll write 6 and 8 there because this is listing. So 6 has already been written, so 8 is the one which I'll write outside there. Then after I do that, I'll look for A intersection C. So if I look for A intersection C, what I'll discover is that I'll compare set C and set A. So from here I can see 10, I can also see 10 there. So after having that information, I can also see a 1, I can also see a 1 there. So that simply means that I have 1, 6 and 10. So these are the 3 members which are in both set A and C. So I'll put my 1 there, I'll also put my 10 there to make it be the set of A intersection C. So intersection A intersection C is having 1, 10 and 6. 6 is the one which is found in all the sets. After I do that, I can easily look for B intersection C. So from the information which I have, set B and set C, what members are they having in common? They are having 4, and they are also having 4 plus a 6 which is already there. So here we have 4 and 6. So where are we going to put? We are going to put a 4 there. So this particular case, A, B intersection C, we have 4 and 6. Then after that, we are going to look at set A only. So set A only, a member which is only in set A. So the member which is only in set A, it's simply 3. So you are going to put a 3 there. Then a member which is in set B only, a member which is in set B only, it's just a 2 there. So you have a 2 there. Then set C only, you discover that set C doesn't have C only, so this part is simply empty. So after doing that, my next target is to know if there is any member which has remained outside. So I'll start comparing. A 1 there I've already indicated, a 2 I've already indicated, a 3 I've already indicated, a 4 I've already indicated, a 5 I haven't indicated it, so 5 will be outside. Then 6 I've already indicated, 7 I've not indicated it, so 7 will be outside also, so 7 will be outside there. And then the other one which will need me to indicate is a 9, so I'll put a 9 somewhere there. And then after that, I'll find that 8 is there, 9, and then 10 is also there. So 5, 7, and 9 are the members which are outside the sets, the subsets. So after getting this information, I can now go in detail and solve question A, question B, and also up to question D. So I'll start with the first one, which is this one here. So for this one, the set is A intersection E, B complement, and then complement. So what I'll do, I can simply change this one using the laws of algebraic. This is the same as A minus what? A minus B complement. So if you look at A minus B, so I can easily pick A minus B. So if you look at A minus B, from A you remove what? B. So what you are remaining with is 1, 1, 3, and 10. 1, 3, and 10. So you have 1, 3, and what? 10. These are A minus B. Now what we are looking for is A minus B complement. So in the universal set, we are just going to remove 1, 3, and what? 10. And then the rest are the members of A minus B complement. So complements simply mean that the members which are not in A minus B. So in this particular case, A minus B will simply be equal to, open bracket, we are going to have 2, we are going to have 4, we are going to have 4, we are going to have 5, we are going to have 6, we are going to have 7, 8, 9, and then 10 is not going to be a member in this particular case. The reason why 10 is not a member in this particular case is because 10 is in what? A minus B. So this was the solution for the first one. Let me quickly look at the next one, which is B. So guys, in case you have a question, please you can register with Excel Academy, or you can simply just contact us in case you want a question. So let's say we have A complement union B, and then you have a complement outside. So what will happen is that I'll not go a long method whereby I look for this and then I relate it to that. No, this can take a long period of time. So what I'll do, I'll multiply this complement by everything which is inside. So this will be A. So A complement times complement, it is simply A, and then there in union will be intersection, and then B complement. So this is the same as A minus what? A minus B. A minus B is a set which we already found there. So in this particular case, our answer, which is just a minus b, will simply be what we have already found, which is 1, 3, and what, and 10. So these are our solutions. So this is just the solution for this particular question. Ladies and gentlemen, if you have a question, feel free to ask in the comment section, or you can WhatsApp us and I'll be able to respond to you. So let me quickly now look at the other parts. Let me quickly look at the last part, which is 3, and then the fourth one I'll give you as an assignment for you to go and solve. So once you solve the assignment, make sure that you send it to our inbox, and I'll be able to respond to you and mark you and state if you are correct or wrong. So we are going to do the third one. So the third one is simply saying A intersection B and then union C. So what we'll do is I'll start with A intersection B. So A intersection B is simply equal to, so look for A intersection B, which is what, 6 and what, and 8. So this is A intersection B. Then this A intersection B, you are uniting it with set C. So this A intersection B, you are uniting it with everything in C. So this simply means that A intersection B, okay, A intersection B union C, it's a set which we can simply write as 1, 2, 4, 6, 8, and what, and 10. So this is A intersection B union C, because C is 1, 10, 6, 4. 1, 10, 6, 4. And then A intersection B, it is 8 and 6, of which you need to know that 8 will be written once, and also 6 will also be written once. So this is how easily you can come up. By the way, not 2 is not part of C. 2 is not part of C, just there. Okay, so this is the final answer for this particular question. Yeah, let me just write it properly, which is 1, 4, 6, 8, and what, and 10. So these are the solution for this set. So guys, for this particular guy, I'll give you as an assignment to go and solve, and please make sure that you submit to my inbox. Let's quickly look at the question 2, which is simplify. So I'll write as my solution, okay, and then in this case I have this particular question. So this one, the first one is P complement union, and then Q minus R, and then you can say this complement. So what I'll do here, I'll simply multiply everything by this complement there. So P complement is simply P, and then union times complement, it's simply intersection. Then you open bracket, you know these brackets are shielding that, so complement times that, you are simply going to have Q minus R, and then complement outside. Then from there I can simply say P intersection, and then what I'll do is I'll change that minus using the difference law, and it's going to be this minus will change to intersection, and then the next expression is going to have a complement. So this whole thing will be Q minus C, or Q minus R will be equal to Q intersection and a complement. Remember there is a complement there, so I'll put a complement there. Then from there I'm going to have P intersection. I can multiply everything there by the complement. So this will be Q complement union R. Okay, as you note is that intersection times complement, it's union, and then Q times complement, it's Q complement, and then R complement times complement, it's just simply R. So if you use the distributive law here, I think that can make this question more expanded, but you can try to analyze the question by simply looking at the Venn diagram. So if we had Q, if we were to assume Q and Q, P and R were joint sets, so let's say we had something like that, and then we have the Venn diagram. So the Venn diagram will just help us to analyze the question and know if at all we have reached or not reached. So let's say this is your P, this is your Q, and this is your what? Your R. So if you check set P is this one I'm shading in green. So in case you want the explanation on how to shade the Venn diagram, please feel free to check out our video which I did on shading the Venn diagram under set operation. Then we have Q complement union R. So Q complement, which is everything outside Q. So this is anything outside Q, okay, anything outside Q like that. And then we are saying union R, so we are just going to add the R part. So if you observe, there is no other way we can move on, or there is no other way we can express this set apart from this way which we have already found. Any going further from this particular point, then that is a distributive, and once you distribute, it simply means that you are making the expression more bigger and complex. So that was the answer for that particular question. Like I've said, if you have any question, feel free to WhatsApp us, and if you have any question, feel free also to register with Excel Academy. Let me quickly look at number 2. So number 2, it is X union, and then you have Y intersection X. So for this one, I'll use the distributive law to work out this expression. So check out on simplifying of sets where I explain something like this. So this, you are going to get your X here, and this X, this is the X I'm getting, and this X you shall unite it with that. So this will be union Y, and then open bracket, and then you get this intersection, you get like that, and then you are going to say X, this X you unite it with that X. So this is how you're going to distribute. So after you distribute that, you are going to have X union Y, and then you say intersection what? Intersection X. Because you know X union X, the answer is simply what? The answer is simply X. So once you do that, once you reach here, when you distribute, it's going to take you back to this one. And when you distribute, it's going to take you back to this one, which will eventually take you back to that one. So there is a way people do it, so they can say X union Y intersection X. Since this one is a big set, okay, this is a big set, and then this one is a small set, and you are uniting this, or you are intersecting this set. So that means that our answer is simply what? Is simply X. But this question can be explained in terms of the Venn diagram. In case you are a beginner, so you can simply use the Venn diagram to analyze this question. So let's say you have set Y and you have set X. So this is your set Y and this is your set X, and then this is your universal set like that. So for you to analyze, you can start with what is in the bracket, which is X union Y. So X union Y, it's simply this whole part. So everything here is X union Y. Please watch the video where I explained on how to shade the Venn diagrams. Then from there, we can also pick up the intersection. So X union Y, it's this one, and then we have X. So if I was to shade X, so this is the part for X, okay, this is the part for X. So if you observe, where are these two sets, the black guy and the purple guy, where are they meeting? So these guys are just simply meeting in what? In X. So this simply means that x union y intersection x is simply what? Is simply x. So this is how easily you can use the Venn diagram to express and solve this question. Let me go on number 3. So number 3 is an easy question. There are so many ways you can solve number 3, but what I'll do is that I'll show you a simple and easy method. So you have M intersection N open bracket union, and then you have M intersection N complement and then bracket. So I'll show you a simple and easy method you can do this question. So what you do is that you look at the one which is common. So the one which is common here is M. So you're going to put M outside, and then that M you're going to unite it with the you're going to get this guy which is in between. So you say union like that. So remember, the easy and short method I've shown you is you get M, okay, which is common, and then you get the union which is there, and lastly you get the last two guys which are N. So you have this guy there and that guy there, and then you intersect them. So you're going to say N intersection E, any complement like that. So this is a shortcut and an easy way you can do it. So from there you can say M, which is this one, and then you can put your union which is there, and then you know N intersection N complement, the answer is what? An empty set. So this is one of the algebraic laws of sets which I've already covered. So you can check out the video on algebraic laws of sets on our YouTube channel, or you can simply register with us. So M union empty set, the answer is just M. So this is just an easy way you can solve this question without even distributing and having a lot of difficulties. Let's quickly look at 4. So 4 is A minus open bracket A intersection E B close bracket. So this can be written as A intersection open bracket A minus C B and then cross bracket intersection. So immediately this this minus changes to intersection. The next expression will have a complement. So once we do that, we can also change what is inside. So this will simply be A intersection, and then the inside will change to A intersection B what? B complement, and that complement will still be maintained. So we now have A intersection. You can simply say A times a complement, it is A complement, and then intersection times complement is simply union, and then B complement times complement, the answer is B. So A intersection A complement, you are going to find that this, you are going to pair it like A intersection A complement. We have paired them using the distributive law. So this one will be paired with that one. Then you get the union there, and then from there you are going to say A intersection what? B, like that. So this one will be paired with that one, you pick the intersection. This one again will be paired with that one, and then the union will be in between. So A intersection A complement, the answer is simply an empty set. Then you say union, and then you say A intersection B. So once you know in an empty set union any given set, the answer is that given set. So in this particular case, the answer is A intersection B. So this is the solution for this particular question. Okay, so with this being found, we can go to question 4. But please guys, make sure that you subscribe to our YouTube channel and make sure that you register with Excel Academy. So the next one is 5. And for 5, it is something which is written open bracket A intersection B close bracket complement, and then union, and then you have A minus B, and then you have that complement there. So if you look at this question is what we already did. So what we are going to do is I'll simplify it at a certain level, and then you guys, once I reach at a level like this one here, you guys, you are going to finish it up. So what I'll say is I'll multiply everything inside by that complement there. So this will be A intersection B. That complement times complement is just 1, and then I say union times complement, the answer is intersection. Then the inside will simply be A minus B, or which will simply be A intersection B complement, and then the complement, that complement times complement, which is there. So what I've done is I've quickly solved this one inside. I've quickly solved it to A intersection B complement. I've quickly solved it to that, and then I've multiplied this complement by what is inside. So from there, this will be A intersection B, and then intersection this times that, this will simply be A complement union, A complement union, and then what you are going to have is simply what? Is simply B, like that. Okay, so this is what we simply have in this particular case. So like I said, once I reach at a point where it will look like this, I'm going to give you as an assignment. So use what I did here. Use what I did here for you to come up with this particular case. So you can easily work out this question by finishing. So please, when you finish, make sure that you submit in my inbox, and I'll be able to respond to you. Okay, with that given, I think even this one you can do it. Though let me just do it so that you guys can easily go through. So you have B complement intersection A union B, like that. So you're going to use the distributive law. So this will be B complement intersection A, and then this one will also be the union, and then you say B complement intersection B, like that. So B complement intersection A can also be written as A intersection B complement, and then union, you know that B complement intersection B is just an empty set. So you are uniting an empty set with a given set. So when you are uniting an empty set with a given set, the answer is that given set. So this is A intersection B complement. So A intersection B complement is also the answer, or you can go further and just say A minus what? B. So either ways, whether you write in that way or this way, it is just correct. So guys, these were the solution for question 2. Let's quickly look at question 3 solution. So question 3 is also an easy question. We just need you to analyze question 3. If A and B are disjoint subset of the universal set, simplify each of the following. So the first thing is for you to understand what a disjoint sets are. So when you talk of disjoint sets, these are sets which are not meeting. So you have set A there, you also have set B. So these two sets are not meeting at any particular point. And these sets are in the universal set, which is this set which I'm drawing right now. So this is your universal set. So after you analyze this particular information, you can now go further and look at the solution for what you have been asked. So the first one is A intersection B. So we have A intersection B. So if you look at A intersection B, if you look at these guys are not meeting, isn't it? Since they are disjoint. So A intersection B is simply what? An empty set. So this is just an empty set. So an empty set can also be written in that particular form, but I would prefer you to use this symbol here. Then the next one is A union B. A union B, okay, A union B, if you look at A union B, it's just this particular region, you unite it with that particular region. So A union B will simply remain as A union B. A union B will simply remain as A union B. Then the next one, which is my third one is simply saying A complement intersection B. Okay, so A complement intersection B is the same as B intersection A complement. So here we have just used the commutative law. So check out my class on the law, the algebraic laws of sets. So from this one, this is the same as B minus A. So from B you remove A, from B you remove A. Automatically you're not removing anything in B. So that simply means that the answer here is just what? It's just B. Then we can look at 4, which is A minus B. So without even wasting time, from A you remove B, automatically you can see it's A is not affected. So the answer is simply what? Is simply A. So this is our final answer. Then the only one which seems to be a little bit tricky is A union B minus C B. So you have A union B and then you are subtracting it, you are subtracting a B. So what will happen is that you have A union B. So A union B is this offset I'm shading in red. So this offset is A union B. So A union B is in red. So I'll write red, which is A union B. And then I can shade B alone. So B, I'll shade it using my blue ink. So this will be my B. So blue is simply representing what? Is simply B. So from red you remove blue, what are you having? You're having this part. Okay, so from red you remove blue, what you are simply having is this particular set here. So that simply means that A union B minus A union B minus B, the answer is simply what? Is simply A. So here the answer was just what? A. So for this question, it was just the game of knowing how to use the Venn diagram, which I have already explained. So guys, if you have any questions, feel free to WhatsApp me on the lines which are 096 588 7474, or you can simply use 0974 84 06 16. So you can use these lines to just simply WhatsApp me and I'll be able to respond to you. So you can send the assignment solution to these same numbers. And in case you want to register with Excel Academy, you can also simply use these same numbers to WhatsApp me and I'll be able to respond to you. Thank you very much for joining me, ladies and gentlemen. This was Dr. Possibility from Excel Academy.